Hello everyone, in this video I will be solving Edexcel P2 Jan 2023 paper WMA1201. So let's get started. So the first question is from chapter integration, and this topic is from trapezium rule. As you can see, we have this curve, and if you need to find the area within a limit of -1 to 1, you need to integrate, right? But instead of doing that, trapezium rule is an alternate method, so we already have this table and you need to estimate this part but using the trapezium rule. So at first let me just write down the formula that we will be using here. So in this formula, y naught is the starting y, as in for each x coordinate you have a different y coordinate, right? So for each of this x coordinate we have a separate y coordinates. First y coordinate is y naught, the last y coordinate is yn, and in between you have y1, y2, y3. So y naught is the starting one, yn is the ending. In between you just add all the remaining y coordinates here. You select the first and the last, substitute them here, and all the remaining one in between you just substitute those values within this bracket. H is the width of each trapezium, as in from the table you just need to select the gap of this x coordinates. So as you can see, the x coordinates are increasing by 0.5, so the difference between two x coordinate is the h. H is basically 0.5, y naught is 2.287. Then inside this bracket I will select this 3 y coordinates, and then the last y coordinate is yn, 2.834. So when you use the calculator, you will get the final result, which is 10.52. So that's it. I'm done with part A. For part B, you need to take help from part A. F of x minus 2. So f of x from a limit of -1 to +1 is what we just calculated in part 1, right? So it's the same thing, but with f of x you have a -2, as in f of x is the y and then -2. F of x dx minus 2 dx. F of x minus 2, you just separate them because y minus 2, so these two are individual terms, so I have just separated them. I will be using part A. This is the result of part A, 10.53, and for this portion we need to integrate them. So integration of 2 is 2x, and then we have a limit of 1 and -1. So I will just substitute the limits now. So in these values of x, we will use 1 first and then the lower limit, -1. So 10.54 minus 2 plus 2, which is 4. So the final result is 6.52. We are done with B1. Next, B2. So if we just look at this pattern, this one is basically f of x minus 2, as in y minus 2. So that's why we just separated this portion, and then the 2 we integrated that individually. But this B2, the 2 is inside the bracket, right? So here we are actually changing the x coordinates. So if we just look at the diagram, whenever you shift the curve upward or downward, area under the curve changes, right? So value changes. That's why we had to solve B1 again. But for B2, it will be the same result as A, as in integration of f of x, integration of f x minus 2, both of them will give us the same result, because changing the x coordinate means the graph will shift 2 unit rightward, right? So this will be 1. So when you shift this, the curve moves 2 units rightward, but the area under the curve remains same, right? So a horizontal shift actually will not change the final result, area under the curve or the value from the trapezium rule. So that's why the answer to B1 is actually 10.53, as in the answer of part A. So we do not need to show any working in this case. And as you can see, the shifting actually changed the limits also, because when you shifted 2 unit, this minus 1, when you shifted this 2 unit, this will be at 0.1, right? When you add it 2, this minus 1 will be plus 1, and the plus 1, initial plus 1, will be shifted at 3. So that's why the new limits are 1 and 3. As you can see, 1 and 3. So whatever it is, the final result is still 10.53. So we do not need to show any working or step. You can just directly write down the answer from part A. So remember, a horizontal shift do not change the area under the curve. Next is number 2, which is from the chapter Differentiation. We will be using a lot of concept from Mensuration. So this is a cuboid. The length of the cuboid is 3x, width or breadth is x, height of the cuboid is h. So at first, let me just list them down. So L equals 3x, B is x, h is h. Okay, so the volume of the brick is given. We need to show the surface area, formula of the surface area, which is 2lb, 2bh, 2lh. If they mentioned it's an open box, in that case we had to use lb. Instead of 2lb, we had to use lb. But since it's not mentioned, we will be using the general formula. So next I will just replace the values of lbh here. After simplifying, we can see that the value of s is in terms of x and h, but the one we have to show is actually in terms of x only. So we have to replace this h, and we can get the value of h from the expression of volume. So volume is 972. So volume is 972. So volume is lbh, length into breadth into height. So from here we can get the value of h, which we will replace here. So L is 3x, bx, h. So h is basically 972 divided by 3x square. So now we will just substitute the h here. So 6x square, 8x into 972 by 3x square. So if I simplify this, one of the x will be cancelled out, and 8 into 972, this will give us 2592 by x. That's it. This is the expression of s. So we are done with part A. For part B, we have to differentiate this expression. D is by dx. So for part B, we will differentiate this. So to differentiate it, we have to have the x at the numerator level. So let me just simplify it a little bit. 6x square, 2592, x to the power minus 1. So d is by dx. So differentiation of x square is what? 2 x to the power 2 minus 1, right? Which is just x to the power 1. Similarly, this minus 1 will be here, and minus 1 minus 1. So we have 12x, 2592 x to the power minus 2. So that's the expression for ds by dx. For part C, we need to find the value of x for which s is stationary. For stationary, ds by dx is 0. For maximum, minimum, turning, stationary, all of this situation represent the same concept. Differentiation is 0. So we need to find the value of x. So ds by dx equals to 0. Therefore, 12x minus 2592, if I shift this at the denominator, now this is equals to 0. So if I take the LCM, you have a 1 over here. So 12x into x square will give us 12x cube equals 0. This will be multiplied by 0, giving us 0 at the right side. So x is basically cube root of 2592 divided by 12, which gives us x equals to 6. Next, find d square s by dx square and show that this value of x found in part C gives us the minimum value. As in, for maximum, for minimum, for stationary, for turning, everything, for each case, the condition is same, ds by dx 0. So to distinguish which one is our case, whether it's actually giving us the minimum, not the maximum, to identify that one, you need to find the second derivative, as in you need to differentiate ds by dx again. So if this one is actually positive, in that case the value is minimum. Okay, so part C, ds by dx is this one. We will differentiate this 12x 2592 x to the power minus 2. So the second derivative is the same process, normal differentiation. So 12x becomes 12 2592, and this x square minus 2 x to the power minus 2 minus 1. So minus minus will give us plus 2592 into 2, 5184 x to the power minus 3. So if since I know the value of x, right, so I will just substitute this here. Without substituting, you can just look at the value and can mention that it's positive, right? But even if you want to find the value, you can calculate that. For example, I got 36, which is positive. So since d square s by dx square is greater than 0, it means x is actually minimum. Okay, next, the last one, find the minimum surface area. As in, we need the surface area is represented by s, so we need to find the value of s. We know the value of x is 6, so we will just substitute the 6 here in this expression. So x equals to 6, s is 6 x square 2592 by x. That's the expression of s. I will just replace the 6. I have just substituted the value of 6 here. So the answer is 648 centimeters square. So that's the solution of number 2. Next question. Number 3 is from binomial expansion. We have this expression which we need to expand, and we just need to solve up to the first 4 terms. Okay, so I'm not using the formula nx and all. For that you need to change the first term into 1. So I will be using the normal pattern, as in 7c1, 7c2, like this. The power is 7. So let me start. Okay, so the first term is 2 and the second term is this entire thing. So the rule is that the first term is 2 to the power 7, as in first term to the power 7. Next, we will just use the pattern 7c1, 7c2, 7c3, and with each of this term, the power of the first term decreases and the power of the second term increases. As in, first term is 2, so the power of 2 was 7, and now the power of 2 will decrease by 1, it will be 6. And the second term, this takes the power from the c. We have 1 here, so that's why the power is 1. Next term is 7c2. Like I said, the power of the first term will decrease, so 2 had a power of 7, then 6, so now it will be 5. And the second term, this will have a power of 2. Next, 7c3, the first term had a power of 7, then 6, 5, so now it will have a power of 4. And kx by 3 will have the power of 3. You can even cross check, the power of the second term increases, 1, 2, 3. Since we need to select 4 term, 1, 2, 3, 4, I'm done. I will just start simplifying this, and here I will just mention a dotted line, as in we have remaining terms, but since we do not need them, I'm just stopping here and just mention a dotted line to represent the continuation of the series. Okay, so 2 to the power 7 is 128. You can get the 7c1, 7c2, 7c3 from the calculator. For example, 7c1. So to get the value from the calculator, you just type 7, and to get c, you just type shift division sign, that will give us c, and then 1 equals. So 7 shift division will give us the c, then press 1 and then equals. So this is actually, this will give us a value of 7. 7c1 is actually 7. 2 to the power 6 is 64, kx by 8. Next, 7c2. So 7 shift division and then 2. So from the calculator, you will get 21. 2 to the power 5 is 32, and square of this, k square, x square, and 8 square is 64. 7c3 from the calculator, you will get 35. 2 to the power 4 is 16. K cube, x cube, 3 cube is, 8. 8 cube is 512. So from the calculator, you can get the value 56 kx. Simplifying this will give us 21 by 2, and the last one 35 by 32. For part B, it is mentioned that the coefficient of x, x squared, and x cubed are the first 3 terms of an arithmetic progression. So the coefficient of x is this 56k, coefficient of x squared and x cubed. We need to pick the coefficients only, and this will be the first 3 terms of an AP series. So and we need to find the values of k. So let me start part B. So 56k is the first term, 21 by 2k squared is the second term, 35 by 32 is the third term. So these are the first three terms of an AP series, and so this is T1, T2, T3. And for any AP series, the common difference is same, right? For example, 3, 5, 7, 9. So the difference is fixed. That's the characteristic of an AP series, right? So you are adding +2 with each of this term. So it means if you select the difference between these two terms, as in T2 minus T1, you get the common difference. If you select the difference between the third and the second term, you still get the difference of 2, right? So from here, the formula is T2 minus T1, T3 minus T2. So now I will just replace this T1, T2 and T3. So next I will just simplify this. At the left side, if I take the LCM, 21k square, we have 1 here, so 56 into 2. 1, 1, 2. At the right side, the LCM of 32 and 2 is actually 32. So this will give us 35k cube, and 32 divided by 2 is actually 16. 16 into 21, 336. Next I can just cancel this, so we have 5, and then I can cross multiply. So I will multiply this thing by 5. Sorry, this is 16. Sorry. So 16 into 21, then 16 into 112, so I will shift everything at the right side. So we have 0 here. I will just shift it at the right side. So at the right side, we already have 35k cube, then minus 36 and minus 36. This will give us minus 672k square, and when you shift this, the sign will be positive. So if we just 35 is 7 into 5. 5 is not divisible by this are not divisible by 5, so we can factorize this using 7. So if I select 7k, this is actually 5k square, 96k 256 equals to 0. So considering this, the value of k is 0, but it is mentioned that k is a non-zero constant, so we need to discard that part. And for the time being, I'm using the calculator to get the values of k. So this will be 16 and 16 by 5. So these are the two possible values of k. That's it. This is the solution of number 3. Number 4 is from the chapter Logarithm, and to solve this, it's better if you actually understand the basic formulas and all the rules of log. I have already explained all the basic rules of this chapter in a separate video. I will be adding the link in the description box. So before solving this question, go through that video for better understanding. So let's start 4-1. So the first step is to select all the logarithmic term and take them at one side. So I will shift the log at the left side. And I will shift the number at the right side. Now, since these two log have the same base, I can just combine them. So instead of selecting 2 log, I will select 1 log, and since we have a minus sign over here, these two terms will be divided. So you need to know the rules of log to solve this chapter, to solve this problem. Then suppose if you have log 5, log x base 5 equals to 2. In that case, if you need to find the value of x, this 5 will be shifted at the right side and it will give us a value of 25, right? This is the rule of logarithm to index form. So I will be using that rule here. So if I subject this part, this will be converted into index form 3 to the power minus 2. Which is 1 by 3 square as in 9. Next, I will just use the cross multiplication concept. So 9 into 4, you get 36x. At the right side, you get 5x plus 7. So 31x 7. So x is 7 by 31. So that's 4, 1. Next part is actually based on sigma notation. So let me just give you a basic idea about sigma notation first. So sigma notation, this sign actually represents that we need to find the sum. We need to find the sum. So we have an suppose we have an expression here. Suppose 2r plus 5 and r equals 1, and we have 4 over here. So this is an example problem to I'm just using this to explain the basic concept of sigma notation. Before starting part 2, I'm just explaining the sigma notation. So the thing is that this part is actually an expression for the nth term or r term. So r is 1. When you substitute r equals to 1, you get the first term. When you substitute r equals to 2, you get the second term. When you substitute r equals to 3, you get the third term. As in, whatever value is given here, you substitute it to get the first term and then increase the value of r by 1. So since we need up to 4, in that case you can calculate t1, t2, t3, t4 and add them up, because we need to find the sum. So the main idea is that whatever we have here, you just replace the value of r here to get the individual terms and then add those values to get the sum. So this one, at the left side you have one sigma notation, at the right side you have another. So let me start with the left side. So r is 1, so when you substitute r equals to 1, you get the first term. When you substitute r equals to 2, you get the second term, right? And since we have just 2 terms, so you just add the first term and the second term. So the first term at the left side is actually log a y to the power 1, as in I'm substituting r equals to 1 here. And then the second term is log y to the power 2, right? So r equals to 1 gives us the first term, r equals to 2 gives us the second term. And since sigma notation itself indicates the sum, so you just add this two. So the left side of the question is this. We will follow the same pattern at the right side. So at the right side, you substitute r equals to 1 to get the first term. So log y base a whole to the power 1, and then substitute r equals to 2 to get the second term, log y base a to the power 2, and then add them up. Okay, so I'm done simplifying at the left and the right. Next we will just try to shift all the log at the left side, but let me just take this 2 at the very beginning, so it just becomes 2 log y base a. This one is log y base a. This one can be this is actually, this is not a power of the number, as in whenever you have the power of the number of log, you can shift it, right? But this 2 is represents that we have 2 individual log multiplied together, so you cannot just shift this here, so you have to keep this as it is. So next it's the same term, right? Y base a, y base a, y base a. So 1 plus 2, and then we have 1 at the right side. So this 1 plus 2 gives us 3. So 3 log a base y. And then if we shift this at the left side, minus log y base a minus log y base a whole square. So 3 minus 1, it gives us 2. You could even simplify this in this line, 2 log y base a. Next you can just factorize this. This is log base a, this is also log y base a, it's the same thing. So I will just factorize this. So if we select this, we are left with 2 only. And since we have a square of this, if we factorize, we are left with another log y base a inside the bracket. So that's it, we are done factorizing this. So log y base a equals 0, and 2 minus log y base a equals to 0. This will give us a value of y equals to 1, but y has to be greater than 1, so that's why we cannot take this part. So you can just continue with the right side. So log y base a is minus 2, so log y base a is 2. Next, when you subject this y, a will be shifted at the right side, and this will give us a square. So this is the final answer. We had to find y in terms of a. So that's it. This is the solution of number 4. For number 5, we have this expression of f of x. X minus 3 is a factor. It means the remainder should be 0. When you substitute x equals to 3, the remainder should be 0. From the factor, you get the value of x equals to 3. We need to show this expression. So I will just find f of 3, as in substituting x into this equation, and this will be equals to 0 because factor means remainder 0. So let me start. And since it's a factor, the remainder should be 0, right? So this expression should be 0. So simplifying this will give us 27. P plus 3, 3 square is 9. this is 0 because remainder equals to 0 here. So we have 9p plus q, and 27 plus 27 minus 3 is actually 51. When you shift this at the right side, it's actually minus 51. So we are done with part A. Next, when f of x is divided by x plus p, it means x is minus p. The remainder is actually 9. It means f of minus p should be 9. And that will give us the second expression. So I will try to find f of minus p. Means I will substitute xp in this expression. And that will be equals to 9. Minus minus will give us plus here. This is actually q. So if I multiply this, I get p cubed, 3p square, p plus q equals 9. So this gets cancelled out. So we are left with 3p square plus p plus q minus 9 equals 0. So 5a, 5b. Done. Next, for part C, we need to find the value of p and q. So we already have the two equations in terms of pq. So suppose this is equation 1, that's equation 2. We just need to solve these two simultaneous equations. So from equation 1, we can find a value of q. So from 1, you get a value of q when you subject this. It's actually minus 51 minus 9p. And then we will substitute this in equation number 2. So putting the value of q in equation number 2. As in this one, we will replace the q here. So 3p square plus p plus q minus, instead of q, we will be writing this value, minus 51 minus 9p, then minus 9 equals to 0. So p minus 9p, that's minus 8p, and minus 51 minus 9 is actually minus 60. So solving this equation, solving this simultaneous equation, 6 into 3 is 180. Since we need 8, you can select 18 and 10. So 3p square minus 18p plus 10p. So p equals to 6, p equals to minus 10 by 3, and p was greater than 0. So you need to discard the negative 1. So the final result is p equals to 6. Value of p is 6, and to get the value of q, we will just replace the value of p in this expression. So q is minus 51 minus 9 into 6, so that will give us minus 105. So next, part D, find an quadratic expression g of x such that f of x equals this. So f of x is a cubic equation, right? F of x is a cubic equation, and any cubic equation can be expressed in terms of its factors. So x minus 3 was a factor, it was originally mentioned in the question. So to get the remaining part, you can either go for long division or third line rule. For the time being, I am using long division. So let me just find the expression of f of x by substituting p and q into this equation. So f of x is x cube, p is 6, q is minus 105. So this is f of x, and this can be expressed in terms of its factors and all. So I need to use long division, and the factor is x minus 3. So x, you need to multiply with x squared to get x cube. So I have selected x square here, so that when you multiply this, you get x cube. So x cube and then 3 into x square minus 3x square. You select a negative sign, the signs of this second expression changes. So the minus will be plus. So this will be cancelled out. 9 plus 3 is 12. Then you shift this minus x here. Next, you need to multiply 12x with this one to get 12x square. So that's why I will select 12x here, and then 12x will be multiplied with both of these terms. So 12x cube and then 3 into 12 minus 3 into 12, 36x. A negative sign will change the sign here, so this will be positive. This is cancelled out, minus x and plus 36, this gives us 35x, and then you shift this 105 here. So x into 35, so that's why I will select 35. This 35 will be multiplied with minus 3, giving us minus 105. So done. So f of x can be expressed as x minus 3 and this quadratic expression. Okay, so this is the final line of f of x, and x minus 3 into something. So x minus 3 into something, this bracket is actually the g of x. So g of x is x square, 12x, 35. Number 6 is from the chapter coordinate geometry, and it's based on the circle equation. So the general equation of a circle is x minus a whole square, y minus b square equals r square, where a and b are the coordinate of the center of the circle, r is the radius. So we need to find the center coordinate, we need to find the radius. So the given equation has to be converted into this format. So for that, we need to use the concept of completing square. So I have a separate video for explaining the completing square concept. So I will be adding the link in the description box. For 6A1, we will start with the completing square concept. So the completing square are actually done separately for x and y. So I will be selecting the x coordinates, x related term together, and I will separate the y. So the x and y are separated, and now I will just use the completing square concept. So it's just that you need to arrange the thing according to this: a squared 2ab plus b square only then you can replace this using a plus b whole square, right? So a square 2 into a into b. I'm selecting 4 so that 4 2s are 8. It has to match the first line, right? Next you need the b square. B is 4, so I need the b square, but this is something I have added in extra, so I need to deduct this to keep the balance, and then we will start completing square of the y related term. So y square minus 2ab. This is for the formula a square 2ab b square. So a square 2 into y into b. You select 2 so that 2 2 is a 4. Then b square, this is extra, so we need to deduct this. Next, the first 3 part is actually the formula a square 2ab plus b square, so this can be expressed as a plus b whole square. The first 3 part is a square minus 2ab plus b square, so this is a minus b. A is y, b is 2, so y minus 2. And the remaining parts are minus 4 and minus 2. So minus 16 minus 4. Minus 16 minus 4 is minus 20. When it is shifted at the right side, it is actually plus 20. So this is the circle equation, and if we compare this with the general format, the circle equation, the center is here, the coordinate of the center is actually minus 4 plus 2, because the formula itself has a minus here, right? So since it's positive, the answer should be negative 4. And this is minus b minus 2, so b is 2. You just need to compare the position, that's it. So the coordinate of the center is this, and at the right side you have r square, so this 20 is actually r square, so r is root over 20, which is 2 root 5. So that's a1 and this is a2. Next, the point P lies on the circle. The tangent at P has the equation this. Find the coordinate of P. As in, you have a circle and you have the circle equation, and there is a tangent at point P. We need to find the point P. So P is the intersecting point of the circle and the tangent. So I have the equation of the circle, I have the equation of the tangent. To get the point P, we will just solve this two equation to get the intersecting point. So the circle equation is this, equation 1, the line equation, tangent equation is this, equation 2. So from equation 2, we can just subject x and then we can replace it here, right? So from equation 2, x is actually minus 2y minus 10, and then I will replace this and the first equation as in the circle equation. So this will be x square y square 8x 4y 0. So in this equation I will replace the expression of x. So that's minus 2y minus 10 whole square, y square 8 into x, which is this one, since we have negative signs over here, we can use a minus b whole square formula obviously, but for that a will be minus 2y, b will be plus 10. but instead of that I can actually just remove the negative signs to make things easier, and this square is actually given to both of this term. Okay, so it's like I'm just factorizing this. So the square is for both of this term. So square of minus 2 is actually, minus 2 square is what? Minus 2 square is 4. You can write it here, or for the time being I'm just keeping this in this format. So this is 4, and this part has to be expanded using a plus b whole square formula. A square 2ab b square. So y square 2 into y into 5, that will give us 10. Then b square, 5 square is 25. Minus 16 minus 4 is minus 20. So I'm multiplying this by 4. 40y, 25 into 4 is 100. So 4 square, y square, it's 5 square. Plus 40 minus 20 is actually plus 20. Then 100 minus 80, 20. So if I factorize this, we get 5 square, 4y plus 4. So 5 will be 0 at the right side if you shift this at the right side. And then solving this middle term equation will give you the values of y. So from this expression, y is actually minus 2. And when you substitute that into the expression of x, x is minus 2y minus 10. X is minus 6. So the point P has a coordinate of minus 6, minus 2. The x coordinate is minus 6, the y coordinate is minus 2. So this is 6b. Next, we need to find the normal, equation of the normal at point P. So basically, normal is the perpendicular line here. This is the normal. So normal is just a straight line. So the equation should be y minus y1 gradient x minus x1. So we need a coordinate and we need the gradient, right? So normal passes through point P. So point P minus 6 minus 2, which we just calculated, is the x1 y1. So the point is x1 y1. So at first I will just find the gradient of this tangent. So from here, if we actually part D. So this is the tangent equation. I will just subject y. So y is actually minus half x minus 5. So comparing this with the general format, y equals to mx plus c, the gradient of this tangent is actually minus half, right? So tangent gradient is minus half. So if we need the gradient of the perpendicular line, normal, you can just convert that using this formula, as in the negative reciprocal. So minus half into m2 minus 1. So m2 is plus 2. This is the gradient of the normal. And the point was x1 y1 was minus 6 minus 2. So equation of the normal is the general the equation of a straight line, any straight line. So x1 is minus 6, y1 is minus 2. minus minus will give us plus. Gradient is 2. So this is 2x plus 10. Done. Number 7 is based on GP sequence, and I have a separate video based on AP and GP series where I have described the formulas and the basic concept. So I will be adding the link in the description box. You can check that video before solving this question. So in this one, the third term is 20, and for the GP series, nth term formula is AR to the power n minus 1, right? So the third term means T3 is given. T3 is 20. T3 means AR to the power 3 minus 1, as in you just substitute the value of n3 in this formula. So from here you get AR square equals to 2. AR square equals to 20. This is equation 1. Similarly, the fifth term is 12.8. So fifth term means T5 is 12.8. So AR to the power 5 minus 1. So AR to the power 4 equals to 12.8. So this is equation 2. So we will be solving these two simultaneous equations. For GP, it's better to actually divide the equation. You can always use substitution process. I prefer this. I prefer dividing this. It makes it easier. So so I'm dividing equation 2 by 1. So from the left side, you will select the values. Equation from the second equation, the left side, AR to the power 4, and from the first equation, AR square. Then I will select values from the right side. So 12.8 divided by 20. So in that way, you can just cancel the A and the R. So the remaining part is just R square. So from here, R is root over 12.8 by 20. Therefore, R is 0.8. So that's it. This is 7a. For 7b, we need to find the value of a. So for that, you can just substitute the value of R in any of this equation. I will be substituting in equation 1. So putting R equals 0.8 in equation 1. Equation 1 is AR square equals 20. So R is 0.8. So from here, A it will be 31.25. For part B, sum of the first n term is greater than 156. R is less than 1. So that's why the formula of sum of n is A 1 minus R to the power n divided by 1 minus R, and it's greater than 156. Next, I will just substitute the values of A and R. R is 0.8, A is 31.25. So 156 into 1 minus 0.8 is 0.2 when you shift this at the right side, and then you divide this by 31.2. That will give us 0.9984. So if we shift this 1 at the right side, so minus 1, so minus 0.0016. When you actually shift this negative sign here, this negative will be cancelled out, but because of this shifting, the less than sign, greater than sign will be converted into less than sign. As in, suppose if you have minus x greater than 4, if you shift this negative sign at the right side, it will be less than minus 4. As in, shifting negative sign changes the inequality sign. So this is 0.8 to the power n less than 0.0016. Next, since the n here is at the power level, so I need to take log on both sides of the equation. I'm not writing the base, assuming it to be 10. So taking log on both sides of the equation. Next, you can just shift this power n at the beginning. So that will be n log 0.8. Next, when you subject n, you need to divide this log. You need to shift this log at the right side. But then again, even if it might look like a positive value, you need to check whether if it's actually a positive value or not. For example, when you use the calculator to get a value of log 0.8, it's actually minus 0.969. It means shifting this log will change this inequality sign, this one, because this is a negative value. So when I'm shifting this at the right side, this is going to change this sign. So from less than, it will be greater than. So n greater than, this is what you get from the calculator, 28.8. So since n is an integer value, n has to be an integer number of terms, so the next integer term is actually 29. So this is number 7. Next is number 8. Number 8 is based on trigonometry. I have a separate video based on the quadrants and the formulas with an example math. So you can check that video before solving this question. This one is actually a little bit complicated because of the involvement of negative angle. We have both positive and negative sides. Even though the question is based on radian mode, I will be solving this in degree mode for because it's easier to actually analyze the range if it's in degree mode. So, and these are the formulas that we will need for positive angle and for negative angle. So let me just start solving this. 8.1, this one. So the first step is to subject the sine part from here, because eventually we need to find the value of x, right? So sine 5 sine 3x plus 0.1 is minus 2. If I shift this 5 at the right side, it's minus 2 by 5. And the given angle is the basic acute angle, which you get from the calculator, basic acute angle. So the basic acute angle is basically sine inverse of this, but you will not use this negative sign. This negative sign is to select the quadrant. We will use that sign to select the quadrant. Calculate the basic acute angle, this bracket portion, you will just use the magnitude. So sine inverse of 2 by 5. So from the calculator, we will get an angle of 23.6 degrees. Like I said, I'm using this in degree mode. And since I will be solving this in degree mode, this 0.1, I will convert that into degree. So from degree to radian, if you need to convert degree to radian, it's actually pi by 180. Similarly, if you need to convert from radian to degree, you just need to multiply the angle by 180 by pi. So 0.1 is in radian mode. If I need to convert this into degree mode, I will multiply this with 180 by pi, which will be 5.73. So instead of 0.1, I will use 5.73 because I will solve this math in degree mode. At the very last line, I will obviously convert all the angles in radian mode. Okay, so this is a problem of sine, and we have a negative sign over here. We need to have an idea about this. This is quadrant 1, 2, 3, 4 all sine, tan, cos. So since we are dealing with sine is positive in first and second quadrant. We have a negative sign over here. It means we need to select the opposite quadrants, third and fourth. So since sine 3x plus 0.1 is, you can use either of these values, let me use 5.73, is negative, angle lies either in third or fourth quadrant. Next, I will just pick values, pick the formulas from the third and fourth quadrant, but then again we need to change the range. So the given range is minus pi by 2 to plus pi. Given range is actually range of x minus pi by 2. The given range is minus pi by 2, greater than minus pi by 2, less than pi. So since I will be dealing with degree mode, so I will use 180 instead of pi. So this will be 90 and this will be 180. So the given range is because of x, but our basic acute angle is 3x plus something, right? So when you multiply the entire range with 3, you get 90 into 3, so 270. X into 3, 180 into 3, which is 540. As in, I'm converting the range. The range should be according to the basic acute angle, this one. So I have multiplied by 3. Next, I need to add 5 plus 5.73 with each and every single term. So minus 270 plus 5.73 will give us 264.3. And 540 plus 5.73 is 545.73. So this is the final range. I will be comparing my answers with this range. As you can see in this problem, we need to work both the positive from 0 to 545.73. These are my positive angles. And from 0 to minus 264.3, these are the negative part, right? So I have to deal with both positive angles and negative angles. So like I said, our quadrants were third and fourth, right? So this is the formula that we will be using. This first part is applicable for positive range of angles, as in 0 to 545 something, and the second portion is applicable for the negative angles. And the quadrants were third and fourth, so I will be picking the formula from the third and fourth. These two are for the positive value, positive range, and this is also from the third and fourth quadrant. 1, 2, 3, 4. So third and fourth quadrant. So third, fourth for the positive range, third, fourth for the negative range. So 3x plus 5.73, this is my basic acute angle. I will have the positive values first. So 180 plus theta. Theta is the basic acute angle, which is actually 23.6. I will replace it later. For the time being, I am just writing the formulas which I have picked considering the quadrants. So these are the 4 formulas. Next, I will just replace this basic acute angle 23.6 in this position of theta. So 180 plus 23.6 will give us 20.6 203.6. Then 360 minus 23.6, as in this is the theta, the basic acute angle. This will be 336.4. Next, when you substitute it here, you will get minus 156.4 minus 23.6. Okay, so next you need to cross check whether all these are within the range. Since all these four values are within the range, I do not need to discard any of it. Plus, we even do not need to rotate, because if you rotate with this plus 360 or something, it goes out of the range, right? So these are the four angles. Next, I will just try to find the values of this. So this is actually the values of 3x plus 5.73. I need to find the value of x, right? So next, I will just subject this. So x equals 203.6 minus 5.73 divided by 3, right? So with each of these values, you just deduct 5.73 divided by 3, as in I am subjecting x. That's it. So I'm not showing the detailed steps. I'm just using the calculator and writing the values. So the first value after subjecting x, this will be 65. This will be 65.96. Next, the second one is 110.2. Next, minus 54.04 minus 9.77. But these are n degree modes, right? These are in degree mode. We need to find the value in radian mode. So at the very last line, I will just multiply this with pi by 180, as in converting degree to radian. So pi by 180, pi by 180. This is the process I follow, but if you are comfortable working with radian mode, you can go for it. I have used degree mode throughout the entire time. Just at the last line, I am just converting the final results, since I need to keep the answers in radian mode. So this will be 1.51, 1.92, minus 0.94, minus 0.17. So these are my final values. Next, number 2. So this is the question. As you can see, we have sine, cos, tan, but then again we need to work with one trigonometric term. So let me simplify it. We know that tan theta is what? Sine theta by cos theta. So that's the formula I will be using here. So 2 instead of tan, I will be writing sine theta by cos theta. Next, if I just simplify this, 2 into sine, as in 2 sine square theta. And this cos, if you shift this at the right side, it's basically 5 cos theta into 5 plus cos theta. So 2 sine square theta equals 5 cos theta, cos square theta. Then again we have cos and cos square theta, but apart from that we also have a sine square, which we need to convert and it has to be expressed in terms of cos, because other terms are in terms of cos. So we know this formula, sine square theta plus cos square theta is 1. So from here you can find the value of sine square theta, which is 1 minus cos square theta. So I will be replacing that here. So it's 1 minus cos square theta. You can solve the middle term equation in this situation, but I prefer replacing cos theta by let cos theta be a, because it's easier to work with a instead of cos related thing. So the equation will become 1 minus a square 5a square. So it's easier to simplify now. So if I shift everything at the right side, we have 5a plus a square plus 2a square minus 2, as in I'm shifting this at the right side. So this is 3a square plus 5a minus 2. So 3a square plus 5a minus 2 equals to 0. So solving this quadratic equation, middle term, you will get two different values. A equals 1 by 3, a equals minus 2. Since cos is a, you need to bring back cos. So if you try to simplify this, cos inverse of 2 gives us math error, so this is not possible. We will just work with this part. So cos theta is 1 by 3. This is our question. Cos theta is 1 by 3. Okay, so next, theta is the basic acute angle. Basic acute angle is theta. So cos inverse of 1 by 3, this will be 70.5. And cos positive, and the range is positive 0 to 360. So that's why you will have to use the first portion only. So cos is positive in first and fourth quadrant. So the formula should be theta and 360 minus theta. So theta is 70.5, this one, and the next one is 360 minus theta. So 289.5. So these are the final values. Number 9 is from the chapter integration. The equation of the curve given, the equation of the line. This is y equals to 2. The equation of the curve x square minus 4x plus 5. So these are given. The first part is about coordinate of D. The curve intersect the y-axis at D. As you can see, the curve intersect the y-axis at D. At y-axis, x equals to 0. So we will just substitute x equals to 0 in this equation of the curve. So for part A, at y-axis, x equals to 0. So the equation will be 0 square minus 4 into 0 plus 5. So this is 5. So 0, 5 is the coordinate of D. Next, for part B, the curve intersect the line at point E and F. As you can see, this is the intersecting point of the curve and the line. So we will just equate these two equations. Equation 1 equals equation 2 to find these intersecting points. So for part B, x square minus 4x plus 5, this is equation 1, equation 2, so equals to 2. So x square minus 4x plus 3 equals to 0. So solving this middle term equation will give you the two values. So x equals to 1, x equals to 3. So E is obviously closer to the origin, so this is supposed to be 1, that's 3. So the x coordinate here is 1, the x coordinate here is 3. And the line is y equals to 2, so this is where y equals to 2 and D is where y equals to 5. Okay, next. Region R, region 2, these are the shaded region as indicated here in this diagram. K is the ratio. K equals area of R1 by area of R2. we need to find the value of k. So basically you will calculate area of R1, area of R2, then you just divide this two, that will give you the value of k. Okay, so we will try to find the area of R1, area of R2, then we will find the value of k. Okay, so for any curve and line, if the area bounded by the line and curve, if you need to find the area bounded by the line and curve, you can just integrate the equation like this, equation of line minus equation of curve, right? Similarly, if it's the opposite, the curve is above and the line is below, the area bounded by them can be calculated using the formula curve minus line, right? So in our case, when we are talking about R1, the curve is above the line, right? This is the line we are talking about, R y equals to 2. So this R1 is actually the area in between curve and line. So we will be using curve minus line concept. For R1, we will be using curve minus line. So R1 is actually integration of curve minus line. And what about the limit? The limit is 0 and 1. 0 and 1. So next, the equation of the curve is x square minus 4x plus 5. Equation of the line is 2. So I will just simplify this, 0 and 1. So x square minus 4x plus 5 minus 2 dx. So x square minus 4x plus 3. Okay, so next when you integrate this, you will get x cubed by 3, 4x square by 2. So eventually this will be 2x square plus 3x. Since I'm done integrating in this line, I will be using the third bracket indicating the limits. Next, you will just substitute the value of x here, right? The limits. So the upper limit is 1. So you will replace all the values of x by 1. Then minus, you will replace all the values of x by 0, which will give us 0 obviously. So the final result will be 4 by 3. So that's the area of R1. That's the area of R1. We also need to calculate the area of R2. So R2 is basically, if we look at this diagram, we can actually calculate this right angle triangle, area of this triangle. Then if I just deduct R1, I will get R2, right? So R2 is basically area of the triangle minus R1. So this triangle, the base of the triangle is this distance, right, which is 3. So half into base into height, right? So half into base is 3, height is this portion, which is 5 minus 2, 3, right? This is at a level of 2, this is at a level of 5. If you deduct this, you get 3. So height is also 3. And R1 is 4 by 3. 4 by 3. So 4.5 minus 4 by 3. This is 19 by 6. And according to the question, our K1 was basically area of R1 divided by area of R2. So 4 by 3 divided by 19 by 6. So the answer is 8 by 19. So this is the solution of number 9. For number 10, n is an integer and 2n square plus n plus 1 is not divisible by 3. That's what we need to prove. So this student has already started this proof with a value of 3k, and he has already proved that this is not a multiple of 3, right? So since this portion, the first portion is multiple of 3, and then a plus 1 means this is not a multiple of 3, right? So we need to complete this proof. So the main idea is that if we are talking about multiple of 3, so the next multiple will be 6, the next multiple will be 9. So eventually you need to cross check from 3, 4 and 5, this 3, because after this 3 we will get 6, 7, 8. The 6, 7, 8 will be kind of a repetition of this whole thing. 3 to the 6, 3 into 3, 9. So if you cover one single cycle, it's more than enough, right? So the student has already started with 3k. So we need to cross check for the next terms. So this is a multiple of 3. So the next term, a multiple of 3 is expressed in terms of 3k. So the next term is actually 3k plus 1. And after that 3k plus 2. You do not need to go for this one because 3k plus 3, this will be the repetition. It's the same thing, multiple of 3. So we need to actually work for 3k, 3k plus 1 and 3k plus 2. And we will try to figure out whether these are divisible by 3 or not. Because it's not possible to keep on working with each of these data, right? So you just show working for one complete cycle, 3, 4, 5, then you are done. So I will start with n equals 3k plus 1. So I need to prove 2n square plus n plus 1. So this will be 2, 3k plus 1, 3k plus 1 plus 1. So I will just simplify this. I will expand this using a plus b whole square formula, which is a square 2ab b square. So 3k square is 9k square. 2 into 3k into 1 as in 2ab. This will be 6k plus 1. So 2 into 9, 18. 6 2s is 12. So 18k square, 15k. And then you have plus 4. So as you can see, we have this part which is a multiple of 3, and with that you have an addition of 4. So that makes it something which is not divisible by 3, right? Because for a term to be divisible by 3, it has to be at a difference of 3. You can even simplify it a little bit further like this. 15k plus 3 plus 1. You can express the 4 as 3 plus 1, so that you can cover this part. So if I select 3, this is 6k square, 5k plus 1. So this portion is a multiple of 3. So if you add plus 1 with a multiple of 3, you will get something which is not divisible by 3, because it's not a multiple of 3. Right? Suppose 6 is a multiple of 3. So if you add plus 1 with 6, you will get 7, which is not divisible by 3, right? So you just need to check whether it's a multiple of 3 or not. So this first portion is a multiple of 3, but apart from that, we are left with plus 1, making it a term not divisible by 3. So we will repeat the same process using 3k plus 2. So a plus b whole square formula, I'm expanding this. 2 into 3 into 6, 2 into 3 into 2. Then b square is 2 square, which is 4. So 2 into 9, 2 into 12, 4 2s are 8. So you get 18k square, then 27k plus 8 plus 2 plus 1, 11. So 11 is not divisible by 3, but then again you can take 8 plus 1 as 9, and then you just keep plus 2 separately, so that you can pick these three terms. You can factorize 6k square, 9k plus 3, then plus 2. So this is a multiple of 3, and since we have a plus 2 with it, this term is not divisible by 3. That's it. This is the solution of number 10. With this, I'm done solving the full paper of P2 Jan 2023. See you in the next video. Till then, take care. Bye-bye.